thank you for your patience. I think there was a delay in the schedule. Let's try to catch up to see how we can do it. But I doesn't want to just catch up. I just wanted to pass on the message that we are supposed to do in this session, right? This is not a kind of a single way delivery. This is a masterclass. That means the intention of this masterclass is to convey certain knowledge sharing. So as per masterclass, I am experienced in certain domain. I don't call myself an expert because I'm a little bit with an exclamatory mark says when you say an expert, that's an open word, right? With the generative AIs and the AIs and the MLs that we talk, the expertise word have to be redefined to see how we wanted to define it. So I have been experienced in this domain. I just wanted to share my experience with the super excited audience here. Myself, Dr. Srini. Don't look at my full word. It's very difficult even for my same group, actually. So the first 5 letter is what you can pronounce me, call me Srini. So I'm going to make it, I had more advanced topic, but depending on the audience, the organizer requested me to kind of make it like meaningful, take it from the base, build them to the level that they can go to the next level so that they take the message back, think on their problem statement, get a solution. That's the intention, okay? I'm going to touch upon 2 main things, very big topics, cloud. When I search in cloud nowadays, right, we go to the search engine and search for cloud, it shows, it's forgetting to show me the real cloud. Now things have changed. You search for Apple, you get something else. You're not getting the real thing which you used to get earlier, right? So that important is cloud computing today. You cannot away or shy away from that. The second one is AI, artificial intelligence, right? So again, there are loosely used words, AI. I wanted a little bit tighten it to see like how we are going to kind of fit it there from the AI, the terminology AI is, and how this is related to Gen AI, how it has been stitched together, and see how you can use that Gen AI capabilities or technology for your background. My understanding, there are different people, heterogeneous kind of a background team. There are also students, this is my understanding from the, so everybody, every stage that you're seen in this 2 days event, they said like these topics, AI, you need young people, Gen Z, the next gen, all people, right? According to me, age is just a number, right? The thinking is what is your age. So thought process, right? You may be 60. I know there are so many colleagues who are even like 60 plus, so energetic and willing to learn. The only thing that is needed today is your willingness to learn. Keep your mind open. All things that I'm saying may not be going as expected on your side. Let me know. There will be a difference in view. That's perfectly fine. We will just try to proceed ahead. So I'm Srini. I'm a telco architect, specialist architect in AWS, covering Middle East and Africa. I'm not going to sell anything here. I'm not here for selling. It's just for a knowledge selling. Okay, that's what we are going to do it here. And I cover Middle East and Africa. I'm based in Dubai. Okay, so I will give my contacts at the last slide. You will be able to reach out to me for any further discussions. I'm happy to do that. So the agenda, always you have to set an agenda before you go for any meeting or anything, right? So I set an agenda, but we will not hard rock thing, right? We will not stick to this agenda. I will go ahead. Certain topics may be of very interest to the audience. I will dive deep there. Certain topics you may, oh, I know this. That's fine, perfectly fine. We'll try to continue as it is. Is it fine? Okay. Please be interactive. Again, I said it is not a lecture, just one way. It is going to be a 2-way conversation. Stop me at any point. There are going to be a lot of words on these slides that may first time you might look at, because certain services that I might show, if you don't have experience on using AWS, maybe looking like a kind of a black box word, but don't worry, just keep it there. I will also mention that. We'll try to understand that from the actual technology. Cloud computing, right? Anybody can guess what? Because there are going to be different definitions here. There are going to be a lot of people think about cloud computing in a different way. Even when I go talk to my customers across, right, they also have a different view of cloud computing as well. That's perfectly fine. So I have a standard definition from AWS perspective. I will just put it there. Let me know. Cloud computing is the delivery of IT resources over the internet, and you consume it like a pay-as-you-go model, right? It's a flexibility, right? And in this case, you are not going to buy, own, or maintain any hardware infrastructure. Okay, so and then what you are going to do is you are going to go consume it as a need basis. That means I'm not going to go build a data center. When I say data center, it may be a real estate. I need to go acquire a land, build a physical wall around it, lock everything, just start buying servers, hardware, start installing operating system. Then the technology, there are a lot of things come in, right? I need to install hypervisors. You spin out your virtual machines. Then on top of it, you bring in a guest operating system. Then you bring in your application. In reality, when you look at it, right, that is not the business of everybody until this point, what I said, right, told, right? Acquiring a real estate, building a physical infrastructure, acquiring servers, building, operating, you deploy an operating system, bring in a hypervisor, bring in a virtual machine, guest operating system. Until now, that's not your business. If somebody is selling something in a retail, he wanted his billing system or something relevant to his retail have to be on top of this. That's the main business logic that he wanted to do. Below all these things are something which is not differentiation for your business. That's why people think like, when I go for cloud computing, I have the flexibility. I spend my time and money for building better differentiating applications on such an environment there. That's what is the value that you're going to see it in cloud computing here. So this is the pictorial representation of the previous definition. This is the traditional way, right? This is the traditional way. Even when I was first buying my desktop computer, I just bought a computer. I don't know what to do with that. I don't know that there was a NIC card. Luckily, I had it. I don't know what was the storage. I still remember the floppy disk. I don't know how many people have seen. I still see the bigger ones, right? There are floppy disk. It doesn't have everything. Storage. You have databases where there, basic stuffs, and then comes your application. This is your traditional way of setting up your infrastructure. But today, when we talk about cloud, why with the terminology cloud, right? You don't know where it is located. Maybe you logically know where it is. You are going to be doing something. All these are readily available. Your server is available, but you don't physically see that server. It is existing there. You have a database. Yes, you have a database, but you don't deploy your database. It's readily available. You consume it, okay? Storage, application, all remains as a service. When I say servers, right, just keep this word. Whenever I say servers, I'm not referring to, in the telco world, we are used to a concept called service means professional services. Whenever I say, right? In the cloud world, whenever I say a service, it is a server as a service, compute as a service. You get the compute, database as a service. That means it is served to you as a customer, right? Storage as a service, you use it, release it when you don't need it. And you pay only for when you use it. That's the idea, intention there. So important thing is basically, oh my God. The internet, right? The connectivity is important. Let's keep it there actually for time being, because this is a connectivity event. You have to be careful. All that was spoken about is all about connectivity, right? The connectivity, right? If I don't have the connectivity from your system to the cloud, nothing is going to work there, right? So you have to be having a reliable connectivity at the required thing. So this is how AWS says, right? AWS owns and maintains the network connected hardware. I'm just saying it, it may be true for other scenarios as well. Keep it like this, okay? You have a network connected infrastructure. You provision and you use what you need. When you go to a restaurant, right, they say self-service. Some restaurants call them a self-service, right? You go, you pick what you want on the screen, you pay, and then things come to you, right? You go pick it up from the counter, right? Very simply, we think it like it's a self-service scenario. This is existing. This is AWS takes care of this side. The left side is AWS takes care of the side. What you do is when you create an account in AWS, that means you're creating, everybody would have created an email account as simple as that, right? Everybody, every single people. I created in 1980 stage. Okay, I'm just 50, close to 50. Okay, you don't think like I know I created my first email. It was so ridiculously kind of feeling like, wow, I did it. That's very simple today. Even I don't know, even like a 10-year kid is able to create his own thing, even though it doesn't allow. He just goes and creates an email account, right? That's how it goes. You have a portal like this. Once you are inside AWS, you create your email ID, your password, everything, then you have this. Then you go choose what service you need. On the right side, what you see, the dotted line box, that is the cloud. That's your cloud, virtual cloud. What you did is, it's a multi-tenancy. We call it as multi-tenancy, right? What does multi-tenancy means? There's a resource available, but everybody is using the same resource, but without knowing who exists in that. That means you have a carved out fence, logical fence for you, secured fence, and you offer that service. That's what you created on the right side. You created, went there, you chose, I need this database, I need this compute, I need this networking capabilities, and that's your cloud. Okay, then you go, I just don't want this compute today, I release it out, delete, release, and then go, okay, tomorrow I have a new version of compute. Right? Today, the generation, the rapid change in the technology is unavoidable. Everybody have to embrace and agree on this, okay? Every day, believe me, the number of emails, updates, technology updates, even I receive, overwhelming. You cannot read every single technology updates that's coming in, very rapid pace. So every day, the processes are changing, the capacities are changing. The storage type is changing. Everything's changing, right? So you can keep releasing things and get the new version and new generation, keep continuing your application at the development, innovation at the rapid pace. That is what you're going to get it on the right side. That's a logical stuff. You always change that logical stuff on the right side. So normally how organization today, like let's take a business that is already established, okay? Let's assume a kind of a business that you are dealing with is already established, be it a telco operator, or be it a retail, or be it a kind of a government entity, or be it a university, because I can see some student faces as well, right? These have been existing, right? You are going to transform yourself now. That means you have invested on certain traditional way of infrastructure. That means you built your data center, you built it. You will not have a business logic to throw them away. If I say, oh, throw this away and go to cloud. No, that's what we are not recommending. That's not the approach, right? It will not make dollar sense for you. Why should I throw it? I just bought it 1 year back, all these infrastructure, right? You are saying to throw it and go to this. The cloud looks good, but still, that's not the idea, right? You need to prepare yourself. Yes, I did an investment. I'm going to do a transition here. That's what we are going to look at. That's the hybrid model, what we talk about. This is not always true for every single customer or any single organization. There may be an organization that is starting to build right from the cloud itself. That means what that means is, today you're planning to build an application for your business. You are starting something, right? You can start from the bottom-up approach. That means your application is built on the cloud. That means that's what we call it as cloud native. You will hear this term everywhere. Everybody will say cloud native. What that cloud native means, I built an application using the entire cloud services, and this is running on, everything is running on cloud native. If somebody comes, okay, yesterday, like the technology, we were calling it as virtualization, right? VMs. Today, we call something called as containers, okay? Some companies, somebody thought that, okay, I put the entire VM was that big, right? It was a virtual machines where, like, say, let's say, like you had 50 vCPUs and that much memory and this much storage, right? Somebody said, I make this entire big machine into one container and said like it is a cloud native. No, that was not the idea, right? Cloud native is something like your application should be able to scale in an independent way. That means there are some portion in your application that will be static. The capacity will be always static. There are some portion in your application that need to grow as your transaction or your business transaction grows. That means I'm not going to scale the entire full application as one virtual machine. Rather, I scale only that part of the business logic. That is what we wanted, that flexibility further to be making to be a cloud native approach. That has to be done there. So hybrid is okay, always good. If you're native, cloud native, you can start there. Okay, I will, now the generic stuffs are done. What I'm going to do is, it is always interesting, AWS as a company, right, has been evolving over years. This is, I would say, like cloud inventor. Nobody will deny it. Even if you go anywhere, search. The first company which brought up the concept called cloud comes from Bird. Excuse me if somebody disagrees, that's fine. That's a reality, actually, okay? So what is that which is going to do? That's the way it goes, right? So there are two things. We call it as one-way decision, door decision. There is a two-way door decision. What that means is certain doors you can open in only one way. When you inside that, right? When the door locks, you cannot open that door. It's a decision is very important in this case. That means investing in your traditional infrastructure is a one-way concept, one-way decision making. That means, let's assume you invested 100 million for building your data centers and you bought like bunch of servers that you suddenly realize that, okay, this technology is obsolete within no time. You cannot make a call because you are stuck with the investment there. This is a big problem in many customers I have seen. I'm just saying it as a practical experience, what we see. Customer understands the technology evolution, but he is also locked to the actual balance sheet that is not saying, oh, in my balance sheet, still it has a value there. I cannot, my management will not accept to approve things because it has a dollar value. It has to depreciate over time and make it zero, and then I'll accept, sir. Sir, by that time, things are going to be a lot of changes are happening, right? That's the problem we talked about the hybrid model in the previous slide, right? It's a two-way decision door when you go to cloud. That means you chose some functions and services from the cloud. Oh, I said, oh, today I used it. I don't want this. Leave this. Tomorrow I go for a different version of a GPU. For example, GPU is a big scarce resource that we are going to talk today about all the AI models that we're going to talk about today, okay? So that's a two-way decision. That means you can always go back and change your decision, what you did, which you cannot do it in the traditional way because the investment is in dollars there. This is a IDC report forecast, basically. People who made the on-premises investment are stuck with the old technologies, and they have to keep them lights on because of what the decision that they made. And the other one is basically you are flexible and you spend your entire budget for the new transformation ideas and innovative ideas because it's a consumption model that we are talking, pay as you grow. Are we good until now? I'm going to a little bit until now. It's not AWS or thing, but it has been mentioned because it's from the IDC report. It's not any specific, it's an external report. You can get that details there. Are we good until now? Yes, please. You're good? Okay. If you have question, please open out. At least it makes meaning for everybody else as well, just to kind of at least keep it like more interactive. Yes, please. Oh, sorry. Yeah, that's important because everybody, that's a very, very, very important point you're raising. Yeah, please.
Okay. What about security and privacy when you use cloud AWS comparing with on-premise cloud?
Okay. This is everybody's concern. Not you are representing the bigger audience, okay? Not just here, the entire world. How many applications you might have on your mobile phone? I'm just putting it in a different way, context. Huh? Every single application you just download. When I came here, I was searching for a taxi service. no, something doesn't work, which because I had some application was not working for me. Immediately I downloaded something local stuff. Do I know anything about this application, where it is, what it is doing, what data? There are certain things you are saying, terms and conditions, accept, right? So security is a perception. You have to, when I say perception, we have so many doors across. Let's look at it from the practical, right? I believe it's all locked. I believe that everything is secure. The lock that you see there now has become smart locks. You agree? Everybody might look into something like a smart lock in your home, and you have an application on your mobile phone, say like, I go, open my lock sitting there. This is what we are doing today. The connectivity is gone that level. I fully agree from an organization perspective who wanted to protect their brand stuff because their end customer or their subscribers are very important for them. Definitely, we can have a big session on security and privacy. And for AWS, it's a top priority. When I talk about security capabilities of an AWS services, you will be amazed. But I said it is a workshop by itself. But I'll tell you, because something called as Nitro Systems. If you find this word, Nitro Systems, it's a AWS proprietary technology for security that provides you confidentiality, your privacy, everything is protected by itself. It is a session by hundreds of slides I can go through and so. But your concern is valid, but we have to address it in a way that you are getting convinced. Okay, I'm coming to that. I have a slide on that specifically. I'll cover this. It's a common cloud means security concept, but not knowingly or unknowingly, we are already in the cloud. Certain areas, privacies, your data is going. Somebody is taking your data, because yesterday when I was clicking that application, taxi application, it says like your data is shared for legitimate purpose. Your location is shared for legitimate purpose. I don't know what is that. I have to accept because I need a taxi. I went and accepted it. Your credit card information is secured. I gave my credit card there. Everything I accepted, right? There are different aspects. Need is something father of innovation as well. Acceptance as well. That is very important. But I fully agree, as an organization, he is serving millions of customers. You have to make sure their customers are secure because their workloads are sitting in cloud. That aspect we are going to do it. I am very concerned. When I was working for a connected car program in 2005 with the US automobile industry, I was a senior researcher there. Privacy was a big concern, big concern. They said nobody will accept because privacy. Today, autonomous vehicle is there on the road. Today, right? There are a lot of cloud stuffs which are happening inside it. Again, I'm saying privacy is there. Concern is addressed. Anonymization of your privacy data is going to be very important there. I'm going here. Cloud, right? When I said cloud, now I'm going into AWS cloud. Okay, Amazon Web Services. We call a global construct, we call it as region. Region, again, you have to be understanding each hyperscalers will have a definition for region. Everybody will say, I have a region. But as per the definition on the slide, it is AWS definition. When you make a kind of an apple to apple, you have to think what is that definition of here is. AWS has 34 regions, and this is a very dynamic growing data, okay? As of now, when I searched the internet and found my data, because I need to find this to get this number updated. 104 availability zones, 600 plus points of presence across the globe. What is a region is? A region is a physical location around the world. Let's say like, today I'm just taking, let's assume Oman, for example. If I say, I call that if we are deploying something in this, then we call that as a region in Oman. Today we have some other services or AWS services, I'll touch up there. It is a cluster of data centers. You have to be very clear. It's a cluster of data centers. We call each group of logical data center as one availability zone. Let's assume you have n number of data center in Oman. I'm going to logically cluster them like into 3 availability zones. Like that is what the availability zone says. Like the availability zone is a collection of 1 or more data center. Okay. And the very important thing is The data center, each with redundant power, networking, and connectivity. That means you will not find a single point of failure of this infrastructure architecture that has been done. That means I have a data center. I have multiple data centers possible in the availability zone. Each data center by itself is independent with power, redundant, networking, everything. And all these availability zones are connected by the backbone there. Actually, it's a reliable, high mesh kind of a connectivity there. And all these regions come, and the regions are also connected backbone. That's how it's a kind of a, you can think it like a mesh connectivity there. No single scenario there. This is very important. Somebody will come and say, I deployed a data center, and that's a region. Okay, that means I built one data center, and that in some definition will be called as a region. In AWS term, a single data center is not a region. Okay, it is availability, minimum 3 availability zones will be there when we call a definition of a region. Each availability zone will have at least 1 or more data centers. That's why the high availability and the redundancy is brought in AWS terminology there. Maybe looking busy, don't worry. On the left side is your kind of a public cloud. This is the bigger construct. The previous slide, what I showed the region, right? This is the AWS region. It has 3 availability zones in this architecture. There can be even more in some regions. There are 3 availability zones. The yellow marked ones are representing a rack of servers. It can be representing multiple data centers, okay? All that you see. On the right extreme, what you see is something AWS can deliver right at the remote site. Let's assume, I'm giving an example, a radio tower, cell phone towers that you have, right? It may be in a mountain, maybe in Muscat, end of the city somewhere, you don't know where it is, it's a remote place. Can I take cloud to that location? Yes, you can. That is what we are showing on the right side. When I say cloud, don't think like I'm moving the data centers there, right? The hardware infrastructure that you see here, it's the same in every thing. Whatever we use in the region, the same hardware, same tools, same experience we are taking to the edge. In this case, it may be one single server that's going to the edge radio site that you see there, which we call it as an outpost family. As I said in the beginning, there will be small new terminologies that will come up. Don't worry, it is our own terminology. Outpost is a product service. We call it as service, okay? Outpost is representing something where you need an on-premises deployment. When I say on-premises, but I wanted the cloud. When I say cloud, what was the beginning in the definition? You have to satisfy the definition. That is the same thing we are doing. We are moving a server with a long cable to that end, where it is. You can think that that server is still connected to this guy, region. But that connectivity doesn't, I will come to that connectivity later. The center point, what you see is local zone. Local zone is a subset of one availability zone. You can think about the availability zone, you see that, right? It is a subset of, I can say it like a smaller version going to customer's premises, or sorry, it's not customer premises, it is into a closer location to the customer. Let's assume in Oman today, as we speak, AWS has a local zone. Okay, AWS has a local zone. Very unique about AWS is you will not know where it is located anywhere. Neither region, neither your availability zones or the local zone is not publicly announced to anybody, because it is highly confidential in the terms like you have multiple customers using that same infrastructure. You have multiple tenants sitting in that. All that you know is it is inside Oman. For example, if I say a local zone, it is inside Oman. At the highest level of the country level, they know it when they approve things, right? So it is not like an individual customer who will know, okay, it is sitting in that building. No, you will not know that. That is the way it has been architected. That is the way it has been done. So you also can have outpost. When I said outpost, I'm just going to go to the next slide. This is how an outpost looks. Outpost, right? This is like you can think about, this is a 40, this we call it as outpost rack, and that one we call it as outpost server. This is the same hardware. You see that AWS, it's the same hardware sitting in an AWS cloud region. You're getting me? It is the same hardware here, outpost rack. It is the same one which is sitting in region. What we are doing is, depending on your capacity requirement, on the use case requirement, you are moving one of the rack from a region, moving it to your place with a cable connected. You think about like a cable, the cable will be different. There are different ways to connect. That is what this event is all about, right? How these are connected. That connectivity is coming there. That is for remote sites. You know about the private networks, all these things. Somebody like an organization which has like a specialized requirement, say that I need a special network for myself, then you can go and deploy your network there on those things. The beauty is the services like compute, storage, your networking, all those stuffs that we are going to talk about. The cloud, if I showed in the cloud, right? It is the same service that extends from the region. It is the same on the outpost track. It is same on the server. Yes, please. Can you be louder at least, Nick? So you can choose your service, and depending on the service, when I say service again, let's assume EC2, I don't know how many, everybody compute, let's assume compute, right? Depending on your need, we will choose the model and stuff, okay? And then you move this right into your place. Because somebody will say like, I don't want my data to leave my premises. That means the data is still there. It is not going to the public region there. It is still there. But all these that you're seeing is a fully managed service from AWS. When I say fully managed, please again, excuse me, in telco world, managed service is a little different than when I say managed service in AWS terminology, okay? In telco, when we say managed services, you built a network, you're operating it, and somebody is going to manage that network for you, right? It's a kind of an outsourced activity. In AWS terminology, when I say managed services, this hardware and the services are AWS responsibility, okay? That means when it comes to you, AWS is monitoring these infrastructures and to see whether these services are available there, patching, right? This is a regular activity. He rightly asked about security stuff. Security is again a continual. AWS is going to patch up these infrastructures regularly with the latest stuff. That is called the life cycle management of these services are taken care by AWS. You are not going to worry about that. That is what we call it as managed services here. Okay. All these are fully managed by AWS, including the region, local zone, outpost rack, your outpost server, everything is managed. But there is also a responsibility with the customer that we will see it as we go ahead. Okay. If somebody is sending you a server, right, to you, you are responsible for the physical security of the server itself, right? AWS doesn't come to your office to see whether you're secure. It's your responsibility to keep that physical security of the server under your responsibility there. It's a shared responsibility matrix. I'll come to that. I'm going one by one on the services, only the key services. We are having close to 300 services in AWS. It's the breadth of the services that you can get in any hyperscaler scenario. It has the highest breadth, close to 300 services available, close to, because they used to call it as 200 plus. 200 pluses keep growing. It has grown beyond 250. Then you have to say we are close to 300 services available on AWS. And depending on the region where you're attaching to, the service differs. Okay, the availability of the service differs. So this is compute, which is a very basic fundamental things. Any customer will start using it. Compute means it can be a CPU, it can be a GPU, it can be performance optimized, it can compute optimized, it can be memory optimized, it can be network optimized, and there are so many things coming in, right? And very interesting thing I'm showing on the right side is Lambda. Again, one more way, don't worry about the terminology, but I'm going to the common word which we use in the technology is called as serverless. Have you heard about the word serverless? No? Okay, this is something which you need to take back. Serverless means when you build your applications, right? Normally in the planning phase of anything, what we do is we plan for the resource ahead. In telco, I worked in 2G, 3G, 4G, now 5G. Now I think, I hope everything God's grace, it's 6G probably is also kicking in. Over the period, right, the planning team have been thinking in the same model, right? What they think is, okay, I need this functionality, but I need to build this application for my network. Think for 5-year plan, growth projection. How did you get that figure? I asked several customers. They said like, okay, I have some formula. Can you tell me, okay, you say like today, this is my capacity. Next year is again, this is my capacity growth, say 20%. Third year is like 30%. Fourth year, and I'm going to double my capacity. This is a normal way of they're doing a planning exercise, right? It is always not true that you will meet that. You may exceed your capacity planning at some point in time, and sometime it can be even lower. So this is a model that they've been adopting, right? In that case, then we said like, okay, the technology came in, which is called as serverless. Serverless means I should have the ability to forget anything, any problem related to the provisioning of the server, the infrastructure underneath. All that I need is a computing environment for you, okay? Let's assume you need 2,000 vCPUs compute, right? Normally when you do is, okay, I buy some hardwares. Normally what you do is you buy hardware. Okay, each are having 64 vCPUs or cores, or whatever it is, you do a calculation and see like I need 10 of them, I need 20 of them. Normally you do that. If you keep that exercise out, forget. All you need is a compute platform, whether it is 2,000 or 10,000 vCPUs, you don't have to worry. Underlying provisioning is taken care. You bring your code, be it on Python, be it on Java, JavaScript, whatever you write, you bring them, just execute it there. It is a runtime platform, we are giving it to you. That is normally forgetting about all the resources underneath, it's all taken care. It automatically scales and shrinks, scale out, scale in. That is what is the terminology all about. I'm making it like a very plain English. Don't take it, it's all, you have to take it with a pinch of salt. That this is to make you understand what a serverless is. Serverless means there is no server, that's not the meaning. There is server behind it, but you don't worry about the server. It is already in the background, the service takes care. You bring your logic, execute it. Once you have done, this Lambda function vanishes. You can make it like a stop state. You don't use it. That's how serverless comes in. We'll go into details. And EKS is a Kubernetes service. This is again a word that you have to be learning. Elastic Kubernetes service from AWS. The building a Kubernetes cluster itself is a big task for many teams. So here it is already readily available. You're going to just provision them and just start using them. EC2 is the servers. So EC2 have different flavors and operating systems supported. It can be Linux, Windows, Mac, ARM-based architecture, x86-based architecture. Now I think there's also GPU stuffs, and everything is there. There are different flavors. It's a big list of instances available in AWS. I will show you when I really wanted to open a real console and show you a small demo there, actually, okay? Don't worry, I will not ask anybody to do a configuration. I'll show you how easy. The way the GenAI will look at it is you don't need anything about the model itself, how the model was designed, how it has been deployed. Rather, I'll make it so easy without code. How do you do that? This is Elastic Kubernetes service without much thing. You have a fully managed Kubernetes service available to you. That means the master nodes, if people understand the Kubernetes cluster, right? You have a minimum of 3 master nodes. There are multiple number of worker nodes available. All that you do is you need to scale the master node as well as scale your worker nodes. All these are fully kind of supported there. You don't do deploy master nodes. You don't do everything. It's all, you save almost, I can say with my personal experience, out of the 100% time, most of the time, 80% I would have spent on just creating a Kubernetes cluster, configuring it, and getting access to it, right? That 80% time gets reduced, maybe like less than 10% of the time is going to be there when you start using the Kubernetes. It's the same open source Kubernetes, hardened and managed fully by AWS. This is the Lambda that I was talking in the previous slide, where it is serverless. For time being, assume it like it. you will very frequently you're hearing something called as event-driven architecture. This is going to be what is your 6G is going to be. The 6G is all about event-driven architecture. What that means is you talk about sustainability. Every company has a sustainability goal, right? What that means, I need to reduce my energy consumption. I need to keep it environment green, everything, right? So that means when you start your server, it is on forever, correct? It is on forever as long as you have your application load running there, you wanted to service. Think about a scenario, I power on something, power it off sometime. I don't need them, right? That is what we call it as an event. So whenever I do a kind of a computation, I need to do some computation, you trigger the Lambda, it comes up, do your magic, goes back. Okay, you're getting me? I can chain multiple Lambda functions to create your service value chain. You're getting me? One Lambda function, let's assume room temperature, whenever temperature goes below normal thermostat scenario, I'm just giving a scenario, right? Goes below 25, just switch off or switch on, right? I'm just giving a bland example here. That can be done by your Lambda. Basically, you can run a logic code there. When temperature goes, your sensor can send a trigger, and that sensor can kind of activate a Lambda. It executes something, switch on, switch off, goes off. This is a big power consumption model that you can think about. This is a big architecture change that you will see in 6G, event-driven. When I say event-driven, you have to chain your different events as well. Not enough. I'm just giving an example. Yeah. A little louder, please, so everybody.
We compare the events versus instances in EC2. So now basically they are the same, but now when we talk about serverless, it's now called events as compared to instances in EC2.
So in the instances type, you know what you need.
Yes.
Correct, right? So that means you choose what is best based on several parameters. You have cost, you have power, you have latency, you have special requirements. You choose one of the instance type and you start executing.
Something ready that you choose.
Yes, very dynamic, right? Yeah. It's a very moving stuff. In Lambda, you specify all that you want and you get, the Lambda takes care of this. Let's assume there are n number of instance types, right? Whatever your instance types you define, and Lambda takes care, provision it, release it.
Okay. So
you're not going to kind of commit for anything here.
Yeah. Great.
These are good for processes that are short-lived. That means if it is like a very long-running thing, we don't recommend doing it in Lambda, right? It's a short-lived event. Because most of if you break your logic and see what it is, there are several short-lived events will happen in your logic. Those short-lived events can, or computations or a logic can go inside Lambda. It saves you cost. It saves you power. It saves you a lot of other things as well. Okay, that's important. It's a business case definition will define what service you will need.
Yes, thanks. Thank you.
Maybe one important thing is this Lambda is connected to most of the AWS services there. It's a naturally integrated. That means you can, from the Lambda, you can call a database service. From the Lambda, you can call another different service, IoT platform. From a Lambda, you can call the observability capabilities. You can call from the Lambda a generative AI model. So that's the way it is going to be kind of, it's already chained there. This is again, every single presenter in the past, in the last 2 days, I'm just seeing, they talk about APIs, network capabilities, exposure, right? 5G is all about any operator here, right, wanted to expose their capability. Until 3G, I won't call 4G because until 3G, all your network is kind of a closed box. Only operator have control over it, okay? In 4G, there was a network exposure capability came in, right? In the 4G standard. That means you have a lot of information inside the network that can be monetized by the operator. That was the intention. That means I have invested so much. If it is just voice, if it is just data, that's not enough, right? That's what they call it as telco to techco. All concepts comes in, right? It's your imagination now. How? So I have a database. I have a location-based services. For example, I'm throwing an example here. Location-based means if I'm connected to Omantel's network, Omantel might know that where I'm located, right? If I'm looking for a taxi, then say, oh, there is so much roamers, he's roaming from Dubai in UAE, from this network to this network. He might be, okay, he came in this time, he can do a lot of prediction and say like, you need 10 taxis to be parked outside the hotel. This is like a proactively, you can say like, okay, I can organize and schedule taxis to go to this location because there are at least this many number of roaming participants are here actually. They can just get that. That's an additional service I'm saying. This can be sold to the taxi company as a service. Correct? It's not like saying this person by name Srini is located in Al Bustan. No, that information is not there. You know that there are 10 or 100 people who's roaming here. There may be local subscribers as well. So that means there's a crowd moving into a specific cell. They will be able to give that information. That is exposing the information to things. So all those can be done through API exposure, and AWS supports all these APIs exposure through a gateway, which is highly available and scalable on need. If you build, that is also not just that. Developers can build their APIs and publish it here. They can test, publish everything on this API gateway. That is at scale. When I say scale, you can think it's okay. Entire country can, all the subscribers or all the customers can do on the same API gateway, and they can still scale. That's the way we are talking. And very, very important, the security and privacy area. AWS, I said it's a top day zero. We don't call it as even day, it's a day zero activity. Security is very important. So identity and access management is a very fine level granular control of your cloud. If you remember that second slide, second or third slide, I was saying there's a logical dotted square where you had all your functions. That is yours. That's yours, right? Your cloud, virtual cloud. The entire access details, everything, whatever you wanted to control, you can create here. There will be one root user for that account, and the root user defines the organization structures. Organization can be multiple departments. Within departments, you can have multiple teams. Each team has a different team members, and each have their own role to play, and there are so many things. It all can be completely controlled by things. We don't call like something like, if you remember, we create users and give them some rights and leave it, right? We recommend going something called as roles. Role is something short-lived. Today, my role is to speak in this masterclass and make sure the audience gets some message out of it, the meaningful message out of it, right? Next cap will come. Everybody will have a different caps, right? So they have keep changing. That is a role. That means it's for the 1.5 hours, right? That's my role here. That is the best way to secure your environment. Don't give a permanent users and keep them available. Managing these users are going to be very difficult. That's why we say like roles are predefined with a specific time period. Beyond that, role will vanish. You can create that way. I'm giving a simple example. It's again, IAM itself is a big topic. Your important topic here is here. This cannot be, see, as I said in one of the presentation, I said in Outpost server, there was a question, right? Security is a shared responsibility. It's not just an Outpost server. It is any services that you consume in AWS is a shared responsibility model. Now let's look closer at this. Security of the cloud. What that means. AWS is building the cloud for you. It's AWS responsibility to maintain the infrastructure or the platform or your services. Because in cloud, when you go, there are different layers, right? Infrastructure as a service, your platform as a service, you have a SaaS, software as a service as a service, whatever it is. All those things, let's assume I'm going to give you EC2, compute, right? It is the responsibility of the AWS to make sure the compute that you have subscribed for is available to you at the guaranteed KPI levels, okay? That is the security of the cloud. We take care of that. On the top, security in the cloud. As AWS, we are transparent. We don't know what you are having inside that. The dotted line which you created, the provision in the beginning, that dotted line is your cloud, virtual private cloud. I don't know what you are running there. What is your data there? What is your application running there? We don't care because you as a customer, bring in those applications, you installed it, You are configuring it, you are managing it, correct? That is the security in the cloud. That is a customer's responsibility. For example, you might install a specific operating system that's needed for on the virtual machine that you got. You are installing your own stuff and you start deploying your application, right? It is your responsibility to patching your operating system that you installed there. And the workload, let's assume you scripted something in Java and then you built an application saying that I'm selling something on e-commerce, you put it there. It is you who are going to be responsible for that, anything related to that security there. That's what we call it as. It's a very clear demarcated stuff. Except for Outpost, there is a little more responsibility on the customer because AWS ships the infrastructure itself to your premises. So it is a customer as customer. You have to secure it physically as well, because AWS is not going to deploy a security person or it's not going to lock your infrastructure, right? Whereas in our own AWS regional availability zones or the data centers that you are logically clustered, AWS takes care all the required standard security procedures are maintained. Even for your example, an AWS as an AWS employee, I cannot go and visit a data center unless need to know what is your role. What is your role? You need to know only for that role, not beyond that. I don't have to go and look how they have put a rack there, how it is cabled. No, there is an engineer or person who is supposed to do that. Only that person alone knows, and that is a highly, highly secure and confidential stuff. Question, please? Yeah, somebody was.
Outpost and the data center. So there'll be some encryption between those points, right?
So data at rest, data at transit, security at rest, data security at rest. That means when I'm storing it in my servers, let's say like an S3 or your database or anywhere, I call it as data at rest, a security at data at rest. When a data moves from point A to point B in your network, data at computation. That means while you do the computation on the data, you have to make sure it is secure as well. That means that is another point that you do. So all these points, you can tick mark that it is completely covered. AWS, any data from your outpost to the region or region to somewhere else, everything is secured by default. But there is another layer that you can bring in on top of it. That is up to you to bring in a kind of another service on top, which you wanted to do another encryption. It's so fine. VPNs, everything you can install.
Yeah.
A lot of stuff there on top of it. And that's what I said. The Nitro system itself is a big topic to discuss. Okay. Confidential computing is another topic to talk about. When I say confidential computing, even you should not know what is happening in some cases. I can give you some other example, but that is what is called confidential computing is also taken care of. This is a key differentiator of using AWS services there, which is very key, which is unique. It's a proprietary technology. And each of these servers that you're seeing, right? The AWS servers come with a hardware key, which is called as Nitro key. You will find that Nitro key is something, if I remove that key, it's like screwing it. You screw with that key, every single server in your, be it in the region, availability zone, or outpost rack, or outpost server, whatever, local zone, whatever it is, has this key. Every individual server has a key. When I install this outpost server, the key comes separate. You have to screw it in, only then the system will get activated. When you remove this key from the system, the entire data is lost. That means it's equivalent to physically destroying the server, right? That's the way it is. The technology is Nitro. And when you understand Nitro, you will appreciate it much more better. That's a topic by itself, okay, as I said. Okay. Jumping topic now. How much time is left out? It's like 1:15 was the previous timing. I think half an hour is left out probably. A little bit refresh your mind. I'm switching from cloud into the another key technology area, which is artificial intelligence. Always we call it as artificial intelligence and machine learning, right? You have never seen like specific, it's a all sub branch of study again, okay? Artificial intelligence I'm just going by something which might be interesting. 1960 to 70. This is where the machine learning concept came in. I was in my engineering in 1994. I had a subject called, already I had a subject called neural networks. I don't know, at that point in time, I learned it because it was part of the curriculum, right? That's how it went. Then we thought like we are doing something on the neural networks because you will learn like, okay, layers. All are neurons, you are representing your human brain concept, how neurons in the brains are connected through networks and each connectivity has a weight, all those did well, the course was well. But today, it is very heavily being used today as we speak, right? That is what deep learning concept that we define is part of the neural network science. And there is something called as Gen AI, right? Gen AI is part of the natural language processing. This topic was already available in 2000, natural language processing, okay? Gen AI is not a new thing. There has been a lot of cooking behind the scenes. The public was not aware of that. When the public was aware is little later. I'm just going to, this slide is going to give you an AWS perspective. You might agree or disagree, that's fact. This is a fact-based database. I'm not cooking the slide. It is actuals, what it is on over the time frame. Statistical models and statistical machine translation, right? First time when you create a ML model, right? When you call machine learning models, AI is the umbrella, right? AI is the hanger for everything. Under AI, you have machine language. Any AI models will have a machine learning model attached to it. Even Gen AI has a machine learning model attached to it. But the way we call it as big LLMs, I'll come to that little later again, okay? So machine learning was there. We created a kind of supervised learning model, was very basic, was there. So I myself have trained a small model. I create a program that says like, okay, differentiate between two things. You give a numerical input, you get a numerical output. A number, based on that number, I was trained actually between some range of set of numbers, you get an output. All that I'm talking is, not even, I'm later than this, 90, okay? So this was even before that, people were doing it, sorry. That is where the accuracy went high. The accuracy means the more the training that you do, the accuracy is better. When you call experienced a fresher, what that means in our terminology, right? We call someone as a fresher. It doesn't, I don't agree, but it's a word, it's being used in the market, right? I call something like I am an experienced core network engineer. Let's say I'm just mobile core network, right? When I say 4G mobile core network to be specific, and within mobile core network, I can say I'm specializing on packet gateways or policy control. That is the way I call it as experience comes over period. What that means, I learned a lot of things. Not somebody has fed it to me forcefully. You do the certification, you go study this. This is a product documentation. This is the installation document. This is a user guide. All this is something comes as natural part of your work culture. There is something else I learned over the period in the job, right? Job-based skill sets. That is what we call it as experience. That doesn't translate it to an expert. Okay, and this is my personal stuff. Don't take it for granted. I may be 26 years experienced in some field, right? It doesn't mean that I say that I'm experienced. I will not call myself expert, telco expert. No. I may be expert in something which I know what how things work. That is what happened here. More data got kind of available at this point in time. 1990, data was very scarce. When I say scarce, you will not find much data to train your models. You have to either synthetically generate something, do something. I create small simulators and then do this, right? That's how we done. So the data start generated here, okay? Then you started getting much there. That is the where 2005, that is where AWS announced about the concept of cloud. That's why I called in the beginning inventor of cloud, right? Why? How did that? Amazon was picking up heavily, right? As an e-commerce service provider, right? Amazon built the cloud for their own use. They had a problem to solve. They had a problem to solve, in-house problem. They started building this concept. And then they realized, why should I just keep it with me, right? I just built it my own problem. The problem is existing for everybody else. Release it. This is what has become a commercial cloud availability. That's how. Then many were there. There are many things, names that you see there are all assisted by some ML models in the background, okay? Machine learning models for time being. This is a problem that is you are familiar with. I made it. Amazon sells 4,000 products per minute. Okay? And there are 1.6 million packages are delivered or sorted out in the logistics. This is a huge logistic process. It's not simple I'm talking about, right? Let's assume there is going to be a requirement for snacks or something relevant to cool, some drinks or something, but what's needed, fresh drinks. I need to know as an Amazon, there is going to be a demand there at this point in time. Only then you will start moving your logistics in such a way that certain part of the logistics move closer to the customer, where the need is going to be. Only then, now you see this Amazon Prime, right? You hear about Amazon Prime? Single day delivery. In some countries, it is a same day delivery. There are some things are there. How this is happening? It's a big logistics strain. You have to move certain demand-based stuffs. These are all done by your ML models, right? It's not so small that AWS is not just doing it today. It has been done every time, right? For its own stuff. Alexa, everybody Alexa, right? So it's an Alexa-based commands. All these have a lot of ML-related services in the background. A lot of things are happening there. Just walkout technology. This is becoming very kind of super hot today because you go to a store. There are stores which are just walkout technology enabled, where you take your stuff, you have a membership in that account, then they know, okay, who came? Computer vision knows that Mr. X has come in. He took 2 apples and just went. The weight of the apple may be something. It knows how things are done. It went out without any, you don't have to go to a billing counter, you do everything. You're automatically kind of billed based on all the subscription that you have done. It's a walkout. This technology is also used in airports. I'm sure in Middle East, you have seen some easy walkthrough stuffs. The technology is the same. So that means all these things that you're seeing are ML-based, machine learning-based, right? Algorithm may be proprietary. Machine learning is all based off algorithm. There can be n number of algorithms. How do you train that algorithm? Is that algorithm meeting the KPI of the person needed, end user? That's it. You have to fine tune it. There is no single answer for anything. Okay, now I'm a little bit going there, which is a kind of the word which everybody talks today. 17 to 22, this is a crucial period. When generative AI coined, the word generative AI was coined there, right? So there was a new algorithm or technology that was coined, which was called as transformer. Okay, this was a published research paper. And based on that research paper, the commercial or the public use Gen AI came in 2022. That is what we call it as ChatGPT was the name launched, right? With a name. It's an application in the front. What you use as a ChatGPT is the front end. Behind that, there are LLMs, right? There are behind that, I'll come to that. That is where people started knowing. Until now, until that point in time, 17 to 22, it is available. It was available in the lab. Only data scientists who were working on that area was aware what is this transformer is, okay? They were doing a lot of research happening in every single companies had it, and they were all. The first throw is the first throw, right? Something is doing something fancy stuff. It is like people got to seeing like, my wife is a professor actually. She says like, before this 22 GPT, even a leave letter, it will be like a 1 word or two 1-line sentence. People like send a kind of letters. Ma'am, I need this, right? Professor, I need this, right? They don't have that thing. Today, even for asking for a small permission, she says like he writes like this. I know it's created by an LLM model, right? But it's very the one side is you created it, right? You created now you see in many offices. Even today, I'm seeing in many emails. I can sense it. Everybody can sense it. What it has been written, right? So it creates a lot of stuff. People start sending emails with bulk contents now. The minutes of meeting have become so lengthier now. Earlier, if you ask like, okay, somebody have to take responsibility to write the minutes of the meeting. Today, we are having a very important meeting, right? Today, AI is doing this role. AI is doing this. It is, everybody is afraid even to talk in some open up in the meeting, right? They say, if I speak, this person said this at this thing, this meeting. It captures that well. So you have to be somewhere, you have to be human now, right? So that is very kind of a scenario. I'm just throwing a scenario, right? So that is where this become popular, Chat GPT NUM convention. In 2023, experimentation and democratization. That means you made it available for people. People started using it as a public. And every company started, there are so many small startups came up in the picture. Every single, I know many colleagues started a new company after this period who says like, I'm offering Gen AI based use case for a special industry, healthcare. I have this telco, I have this and this. So that all came up, everything started experimentation, everything started coming up, right? So they say like these words, Anthropic Cloud, Amazon Titan, Open API, GPT-4 and stuff, A121. That's this is kind of a research institute in UAE. That's what I think. The level of innovation and stuff everywhere globally become like so stable. So many open source models come up. It was like, it is a very, and this word everybody would have heard, right? Hallucination. I'm happy that this word used to be a kind of a TOEFL word. When I was studying a TOEFL or an IELTS, we used to take the number of list of vocabularies and start learning. That hallucination at that point in time, I used to by heart. What is hallucination? Now, every single person, this is a thing, everybody says hallucination. I don't know how many people understand what does that means. It is like these models sometimes become more smarter in the sense like you make it more smart. As a human, we make it more smarter, and it throws out something with a confidence level that you believe that it's correct. You ask some question, it gives a very good, elaborative, very systematic way of representing things, and you believe that it is correct. In reality, nobody has validated it. It may be wrong. The concept itself, what it is throwing to you is wrong. That's kind of you can think of hallucination as a kind of you need to kind of create a framework to control it. We'll look at that later. There is something called as in the orange, which is called as RAG. It is a model or a framework through which you can reduce hallucination. Okay, I'll come to that. I have a detail. 2024 is a production year. It is everybody is trying a models, Gen AI based stuff at a scale. So what we are thinking is models are getting better as AWS. Models are getting better, cheaper. The price has reduced by 80% over the past 18 months, because this is what the market is coming to the reality, right? You need to, how that is, we'll just look at it later. Agentic systems, right? You need to have certain kind of autonomy to your system, right? This is very important. This is also seen in now, as we speak today, right? This is a big concept there. I will come to that also. There's each slide, all these have separate one slide for each of this. At least regulations started speaking out. Especially Europe is very sensitive to the question, privacy, data, all those stuff, right? There are models, you accept terms, you go again like it's a bank documentation, right? Normally you accept terms, you don't know for what your data is being used. That's why every corporation was kind of warning, don't use your open thing, which is uncontrolled, unguardrated solution, giving some sensitive information, right? You might wantingly or unwantingly will give it without knowing it, right? So that's why there was something very sensitive have to be kind of thing. That is what the act, it has to be regulated as well. That's coming up. What should you continue, right? Every company have access to the same model. That's true, right? Everybody have access to the same model. what is the differentiator is your data. Your data is very important. And that's the differentiation. There is something called as data foundational framework has to be put in place. That means you need to know how easily you can handle your data. The ETL process, we will call it as, you get the data, you clean the data, you label it or unlabeled data, whatever it is, you train the model, a lot of things are happening. That framework is a set of tools, okay? It's not easy. I will tell you how it is made easy. Invest on capabilities that we know won't change. That means keep aside the model. There are some framework is needed. Plug in the model to see it do. It doesn't do, throw the model. Bring in another model, right? So that means I need certain things that need to be invested here. And you spend time in that. Guardrails. Guardrails is very important. You have to instruct your model what to do, what not to do, right? That is very important. That's what you have to put a guardrail to your models, what you are going to test for your case. LLM evaluation tools, right? I have so many LLMs in the market. LLMs is large language model, right? We are saying large language model because it's large because it is billions of data or vectors are going to be used to train this particular model. Earlier model was not large language model because you didn't have that volume of data that we have today, okay? So all these are monitoring, governance, responsible AI. AI can throw a lot of nonsense as well sometimes, right? So you ask for something, it will send you something obscure as well. Those scenarios have to be responsibly AI, right? Certain contents you should not be able to do it. Every culture, every region, every regulations need a specific things. All these are going to be responsible AIs. How AWS sees it? Every customer needs a low cost, right? You have to be having a system that is low cost. Innovation and choice. You need a choice. You need a security framework and governance capability for a model. This is how AWS sees it. And how do we do it is based on our service. I will come to it, something called as Bedrock. I will just log in and show you this. Approach little bit, Amazon is looking a little different. Like what you said, like there are publicly available models which you use it for regular content summarization, your leave letters, your excuse to your managers or leaders, everything. All those are regular stuff which you access. There are focus of AWS is basically the business customers. That means, for example, if a telco operator or a big enterprise or a big airlines, if a big kind of all the big enterprises or SMEs or whoever it is wanted to do something, then we give you that very framework that's going to making sense. We believe there isn't and won't be a one best foundation model. This is our view, okay? There is no, today you have like, let's assume 50 foundation models. This is going to grow. Every small researcher is trying to develop something on his own, right? There is not going to be one single that's going to solve your problem. This is going to be changing. Solution at all levels is what AWS wanted to handle. When I say solution, right? You have access to LLM models or your whatever you call it as GenAI applications, everything. Underneath that, there are different layers. What you are exposed is the interface alone. You are accessing them, right? Underneath, you need the infrastructure. That is why all this GPU stuffs are becoming bigly known, right? What is happening is you need an infrastructure there to train your model, design, build, train your model, and it's not small. It's not small. You need that scale of infrastructure. If somebody thinks like I will invest on a infrastructure to build my model, train my model, just please think about it. That is your business? Are you going to offer this as a service to somebody else? Then think about it. Otherwise, if you wanted to use a model for you, don't build these things, right? It's not going to make sense at all for you to that. We are going to give you that layer of infrastructure, your requirements. Next layer is basically the models available, right? The models have to be exposed to you. What we did is we wanted to create a kind of environment where you have access to all the models that is available, popularly available there. That is what AWS did. The service which you call it as Bedrock is a framework where you can access anthropic models, meta models, meta-based models like this, Llama. You use AI21 Labs model or anybody else, right? Most of the things you will see that even AWS models, Titan. Okay, all these are exposed in one single service. So you use it, plug and play, test what is suitable for you. That's the way we are going to look at it. That's why we say like we provide you the underlying hardware solution, data service needs, whatever scientist needs, all those services are available on AWS, and the business users will use it on top of that. That is how we are thinking about it. And the last one is very important, but those services are available for them. How does AWS Gen AI, no, not AWS, it's the general stuff. 11 more minutes. Oh, sorry, 14, 20, less than 20 minutes. Okay. Very important. AI that can produce original content close enough to the human being generated content is what is we call it as generative AI, right? That's the word is we are using it. Powered by foundational models. This is powered by foundational models. Foundational models from multiple companies, multiple people, whoever created it. It's all going to be underneath. Customized specific to your needs. If you are from telco, if you are from banking, if you are from healthcare, if you are from retail, if you are from transportation, energy, you have to specific domain knowledge have to be injected to that specific foundational model so that your closeness of accuracy of the results are going to be better there. Use cases, this is like, I will leave it to you. This is, you know it actually. This is like text generation, image generation, because everybody shows an image saying that this was generated by AI. Maybe they don't know which model was behind that. Why that's not looking good. Okay, each model might generate the same for the same prompt query. You can get a different images as well. I'm just showing you this important slide, which may be very interesting for you all. Machine learning, simple input, simple output. It was mostly numerical. That is the original setup, right? Deep learning, the neural network concept came in, where you had you can have a complex input. When I say complex input, think about you're feeding in an image with your face and say that identify this guy. Who's this guy in this, right? So that's like it will be able to say this was a star here and this particular place and all that information you can get. That is the simple output. It says this person name is this, something like this. It's based on a training. Foundational model, input is complex, output is also complex. That means when I say complex, don't take the word. It's a multi-model in the sense like you can give data, you can have a video, you can have a voice, you can have a combination of this to make a complex decision as well. That is what we are calling it as foundational model, because it's able to do this because you have trained it with all sort of data there. Foundational model is like a human, right? You can think about not just human. I just cannot say it's like the vast is like you can think about every human, whatever you know has been trained. Let's assume for an example, right? But you have to calm down or cool this guy to make the job for you. That is what you have to do, right? That's what we are thinking about. What it can do well. Don't think that GenAI do everything for you. It will not serve you a coffee or a plate of food for you. It will not do that, right? It can tell you where it is, all these stuff. It can do summarization. You have a 10,000 page of a book. Let's assume I'm giving an example, right? I just can get you a summary what that book means, right? What is important. It can be in a conversational way or it can be a text way, whatever way you wanted, it can give you. It's a summarization is okay. For example, user manual, you get a kind of a switch at your home and you wanted to configure it, right? You say, oh, there is a manual, I upload the PDF file and then you get a summary. What are the steps that you need to do? Simple summarization of that. Code generation, yes, it can do. It is doing. And I think we are agreeing that it can write a code which can work, which is working. But is it optimized? Is it doing the way you wanted a team to do it? That is up to you. You need to again tune it again. It can do. It can give you 100 line of code. I can, as a human intelligence, I can do it in like a 10 line of code, the same logic. Sometimes, I'm just giving an example there. Language translation, it can give you any language. This is a big, big boom. This I can say you like, now I'm very happy. Maybe whenever I come any Arabic board, I'm very happy. I can just scan, and it gives you like, okay, whatever language you wanted. I don't want to say what language. It's very interesting, anything. It may be useful even on a, think about a car that can understand this, right? Traffic boards, directions, all these are kind of able to, whatever language it is, like a bunch language, any country you're driving in, you'll be able to get that sense of the context to you, okay, where you are there. Paraphrasing, classification, I leave it. All these are like very simple. These are something, there are limitations. These are limitations. Certain things Gen AI cannot do. Max and reasoning, right? This is a question mark area. It is evolving. It is evolving. It cannot think like a human being, like doing certain scenarios, okay? It can give you something different. Rest all, I will leave it for you to read. I will put all the bullets. I'm sure you heard about all these terminologies at some point in time. Now, why I put this, you have to be clear what you are talking about, right? So vector, embedding, parameters. These are three things important in a large language model. Vector means it is representation of the training data that you gave to this model in a vector database, okay? That means you have 100 billion of data flood into this model. You're training them, right? You have to represent kind of these data. Cannot store all the 100 billion there, right? I need to represent numerically. Vector is a kind of a representation of the data that you trained inside your large language model. If this is for data scientist or somebody who wanted to. Embedding. Again, embedding is a context of the vector that is again stored in the vectors that was generated was stored in a database. That's a vector database, right? So I will be able to easily search based on this vectors. Vectors are numerical values along with the representation direction where it is going, right? It is going, let's say, with the direction. There are multiple vector domains within an LLM model. Let's assume you are training with telco data, right? All the telco related stuff goes into a vector domain that falls under, let's assume, telco related queries and stuff. I'm just trying. Searching text is very difficult. Instead, make it numerical and make it representation in the database. Parameters, basically, how many parameters on which that model is trained, that's how defines your LLM large language. See that Llama 2, 7 billion. 7B is representing the billion amount of data that's there. Every model will have 405B, Llama 3.1. 405. There is a huge difference, right? That is what is kind of representing the parameter on which it has been trained on. Prompt engineering, very important. It might look simple. I ask question, it says answer, right? No. You ask something, it gives something, right? Prompt is a way of designing your question, right formatting of your question, so that you get a response also in the format that you expect. Prompt engineering by itself is very important. Every person who wanted to use have to have prompt engineering. RAG is retrieval augmented generation. What it says is when I wanted to put an LLM for use in a company or for an organization, right? I said in the one slide, like data, your own data is the differentiation, not the entire model. Everybody have Llama 3.1. What is my differentiation, right? It is your data. That is what you're going to get a kind of external fine-tuning of your stuff with the RAG model, where you populate your data and add it to the model there. Agentic systems are autonomous systems that can make decision based on the context of your questions and also able to take action. It understands your context, it makes decision, and also takes an action. That is very important. Think about you're talking to a virtual agent, right? Virtual agent in an airport, you ask, okay, which terminal should I find this flight? Where is the gate number? All these things. Now people are not there, right? Sometimes you see a screen populating something, virtual assistant. You talk to them, it learns the context where you are. You are in this terminal, where it should go. If the terminal 1 is not your right place, go to terminal 2. It need to understand the context. You gave the context and also take you an action, say that, okay, this bus is starting at this point in time. You can take this bus and you'll reach there and get this. All these things can be done there. I'm just giving an example. Pre-training is something like you build your model, LLM model, you train it with your data. It's training the model, okay? Retraining is you have another bunch of data coming from the organization. There is an LLM model. You retrain that model to make it domain specific. Fine-tuning is, again, you have labeled and unlabeled, right? Labeled means network operations, for example, I'm saying, right? I need to do some operation act automation in the radio side. I can do very specific training on that particular domain there itself. This slide is very important. You need to make a judgment. Unless you don't understand what is my use case, you are going to somehow land into a wrong model usage, right? So all models are not the same, as I said in the beginning. Is it your use case is text generation? Is it an image generation? Is it a multimodal generation? Is it an embedding model? Depending on the model, you have to go into that class of models available. What that model helps me to do that? Is it giving me the right? It's an iterative process. Okay, some models may be more expensive for you. Some model may not be meeting your delay, latency criteria and stuffs. You have to, this is a big mindset you need. So small models, not all models are LLM. They don't call it as LLM, large language model. There are small language models, SLM. SLM is also becoming very, very popular. Back again, we are going one step back. That means I build a model with a specific use case. I have multiple LLM models deployed in my organization. All these LLM models can talk to get more meaningful inputs there. So that is making like the cost accuracy. This is a kind of a play around. If you increase, your cost goes up, accuracy may be improved, but your latency, because it's processing that huge amount of 300 billion stuffs, right? It's not maybe 1 billion. It can search for the latency. So it's a lot of KPIs, trademarks, KPIs that you need to make a judgment before you create a use case for your organization. And just that's why I said it's not all the same. Okay. This is the implementation strategy. You have to see from here. I have a LLM model. My budget is very limited, but I have the prompt engineering capabilities. So I can put all the guardrails, everything. I say like you are going to change the context of the thing. You are an expert in this particular field. You set the context. You set the LLM to say that, okay, I'm going to have this cap and start rolling around that, right? Then you can do a lot of stuff with the prompt engineering itself. There is another one, RAG, for an organization that needs to have specific hallucination reduction and stuffs, right? So then you go for a RAG. You already have a database in-house. You just plug it in. And then agentic, depending on the use case, again, you need to take actions, fine-tuning. Fine-tuning is domain-specific knowledge you're bringing it up. And then retraining is something like you can retrain because it's a continuous process. The data will get obsolete. This is prompt engineering. I'm not going to much. You are all experiencing prompt engineering. You're doing it. You are creating, ask all a lot of questions there. But it is an art by itself. This is a separate subject to study, because you will see like even I can inject in the prompt itself some specific images, specific codes, specific stuff to make it like, okay, I need this kind of a financial report for this organization based on this and stuff. You have to create, it's an art by itself. I'm just going to do a kind of a quick forward. This is a RAG model. What we are doing is RAG is, so what I did is, this is my storage. All the organizational data are stored here. You feed that to the model, train that, pre-train, or you call it as retrain that model. So this is called as embedded model. This is embedding model, means it converts all your data here in this bucket embedded into a vector database. It represents it. Why? You need to quickly search for information from your database, right? I cannot directly do that. I can also do it in a different way. Then you ask your query. Your prompt engineering comes from here. It enters your your application is here. It gets into an API gateway. If you remember, I was telling, right? You are exposing it through an API. Then API goes to Lambda. Lambda was a server compute, because every time you ask a question, this Lambda comes up, execute your code, and goes off. It's an orchestrator kind of stuff. Then it sends a query here. I ask a query. Let's assume an example in your case, right? I wanted to configure a specific database with this particular specification stuff. You go, those embedded values are coming from there. It searches, okay, you can find the answer for this from this document based on this embedded vector database. Then that result, along with your query, goes to the LLM model. This is the LLM model. Okay. The bedrock is the AWS service, where you have all the LLM models. You can remove this, plug in something something like that, okay? You can get a lot of things, and then your result comes back in a better way. This is a RAG model. If you remove that last storage bucket, it's a normal standard LLM approach, right? Your hallucination will be there. Again, here you're going to control that hallucination here by just controlling it. Okay, answer based on only the content that I've given, but you're using a language model that makes meaningful response, like a letter that I was talking, emails that I'm talking about. Okay. This is an example for an agent systems. Basically, it is more like it does two things, right? Knowledge base, and there is an action that it can take. This is an example where HR database, HR use case. Every company, every organization has an HR concept. I wanted to understand leave. This is the most common stuff. How many leave left out, right? You have to log in, you have to do a lot of things, right? What we are trying to do is you make it like this. How much vacation do I have per year? Based on the policy, you have this many years, and you have 3 years, you have 15, all these things. You ask, okay, I wanted to take leave from 8th to 15th, something, right? You give a date, November 8th to 15th, I wanted to take a holiday, then say, okay, I'll create a leave entry there in the system, and then send back that you're all done, you can go and enjoy your holiday, right? Your deduction, everything happens on the backend system. That is what it's going to happen. Now you have to go apply for the leave, right? Everything, I'm just giving an example. If you don't have holiday, it'll say, okay, you have to work more than that. I'm just giving an example. This is how it goes. This is a more and more functional representation, how this can be implemented. Okay. You have these, all these services. Those are maybe your on-prem stuff, which is existing today. All these can be the box in the center. You can implement with AWS Bedrock kind of service there. Fine tuning, I'm showing it quicker here. I'm going to close in 5 minutes. Give me a minute. So fine tuning is you can always tune it with all your data bucket. This storage, right? This green bucket represents an AWS service called as S3. S3 is an object storage. You can have anything inside that, and you can start training your model. It's at scale. Prompt engineering, do it. Fine tune, if it's not, your answer is not there, you can continue on that. This is a complete building your own LLM. Retraining and fine tuning as well, depending on the cost and your factors of KPIs, you can do these approaches. This is very, very, very useful. If you want it, you can think about it wherever you are, whatever organization you are. You have to ask the right question before you jump into say that I need an LLM, right? I'm just going to do it like this. You need to know what task, what you are going to accomplish. The first white box is all the decision boxes, right? Ask this question. What task is what I'm going to achieve, right? Otherwise, don't say that I wanted to implement GenAI. No, that's not the thing. You define what task you want to achieve. Is it external data sources or up to the data information, what's available, or your history? It should be a naturally continuous process. It's a decision is very important. This is for a leaders or a decision maker within an organization who wanted to bring in the GenAI capabilities, have to make this through, right? Real time, yes, it's real time. It's a relatively static information I have. It can change sometimes, then go into the RAG model. That means, HR policies won't change over every day or every minute, right? So then I say, I know relatively it's okay. Maybe 6 months once something might change. I put it into the RAG model. No, my thing is very changing one, right? Then you go for the agent model. That means every context, every environmental parameters, everything keeps changing there, right? Then you go choose, okay, I need to go this approach. This is all example. Don't say like it's written there, right? It's again based on your discussion there. Is it a simple task or thing? Again, you choose here. This is what Bedrock, all these words, SageMaker, all these are AWS services again. Okay, Amazon AWS. That's my context. I'm done. Only one thing I will, 2 minutes. Okay. So this is my AWS cloud stuff account. This is how you will see it when you get yourself signed into an AWS account. This is my own, I'm on this region. See here. You see that there? Virginia, North Virginia is my region where I have got in, right? When I click this, you see all the regions available. I go pull down to see all the regions. Middle East, you see Bahrain, UAE there, region. So even the local zones that I talk about, Oman, maybe attached to one of that region. You can, once you are inside the region, you will be able to find the AWS services in Oman as well later there actually, okay? That's how it goes. So just I'm giving you an example. I'm just going there. Now, I was talking about a lot of services, right? You see them here. EC2. Yeah, this mouse is killing me. EC2 here, you see them? Inside EC2, you'll be able to create a lot of stuff. S3, I told you. Amazon SageMaker, Amazon Bedrock. I'm going to go, if you are not able to find it here, you can, this is like your search bar here. In the search bar on the top, you just type EC2. You will get that there, okay? I'm going to go into Bedrock. I'm in US East 1, okay? I'm inside, going into the service for Bedrock inside it. Why I wanted is, I told you that this is a kind of, I'm on the foundational model on the left. I just click base models. These are all the models that are available in Bedrock. That means it's not easy. This is a framework I'm telling about, right? You need that framework for benchmarking your LLM models for your specific scenario. If you try to build something, you might have one model, you might build the second model, that's it, right? Here it is, I'm just going into this mode actually, at least for, you see them? Cloud 3.5 HiQ, you Cloud 3.5 Sonnet. These are all models which are very, very kind of every people try to use it here, right? Cloud, Opus, Commander, Embed Multimodal, Jamba. There are certain things which are legacy. That means it's an old version. You have new versions coming in. All these are lifecycle managed by AWS. Okay, you don't have to manage it. And you see Llama. These are all meta models. Mistral. You have so many Titans are AWS models. So this is like, you can think about like an LLM marketplace, right? This is the interesting that is, now you say today I wanted to use this model. Try what's my result, right? You use it, use the APIs. Your single API call, you can consume this service there. Tomorrow you say, okay, let me try another model which is maybe more cost efficient than what I used here, right? Because cost is something like based on something called as token. Tokens are something like your words, a query, the prompt that you gave, right? Or can be a word-based count, or the response that you got from them are called as tokens. Inside query, response. These are called tokens. Based on the tokens, you would have consumed so much resources in the background, so your charge might change. Each model might resource consumption may be different. There are so many models there, right? And also in this part, in this column, you see this? They are good in these. It's giving an instruction that this model, Mistral small, is good in text related. And there is a description there, right? Now you can go and try in that particular class of models what you really wanted to try it out. And then there are some examples here. You can go try this out. You have already pre-built use cases that are there. You can go just use them. It's for text summarization. You see them on this blue box, which is highlighted here, this particular scenario. This is very, you see them, lot of pre-built scenarios are there. Text generation, video, your image generation, everything, earning call analysis, right? That means like you wanted to understand your financial report of the company. All these are like you can check and use it. There are so many are there. This is just, I'm just giving you an example, like this is the flexibility of the cloud AWS that gives you there. You are not restricted to, all these models are not AWS models. There are Titan, which if you wanted, you can use it. If you wanted to use Anthropic, you can go and use it. We believe as AWS that you should have that right framework for experimenting your stuff for your use case. That's the idea there. We are not restricting ourselves to use this model. No, we don't tell you. It's just because it's coming from AWS. No, we have to work backward from the customer. It's our principle. We don't work on something short-term benefit for losing the long-term trust and business. We say like, do the right thing. As an architect, I will be an advisor for my customer. Make the right thing, which makes sense for you. We are going to solve your problem. That's the idea. Thank you, everyone. I think I had a lot of demos, but I think time constraint was there. I'll leave it. Thanks. Any question? Any general stuff what we can do? Then go back. There are certain services free. Account, you can create your account free, but be conscious of what you consume, because cloud is very fascinating. You start consuming more, it's like your electricity or water. You will start consuming more. There is a free tier, so much you can use for free. If you exceed that, your bill will. So careful, and just, it's experimental. It's nothing wrong actually. Okay. Or if you wanted more details, reach out to AWS and we are good to help you with this.
Excuse me?
Please.
So when I see the platform there, mentioned there is regions, Bahrain and UAE. So Oman itself currently it's part of these or it is separate?
So if you remember, I was telling you a different types of architecture, right? One was a region on the left side, which is a bigger construct of AWS.
Okay.
There is a middle part which you see local zone. Local zone is a same infrastructure and services, but it is inside Oman.
Okay.
It is inside Oman. That means when you connect via this region, because always they are parented to a region, but your data, everything sits in Oman. You can get into that region from the account, then say that I need to provision my EC2 compute and storage in AWS local zone in Oman, in Muscat or whatever it is showed there. You can search and you can go deep into that. So your service will still run in here, Oman. It is, though it is anchored to, let's assume I'm throwing an example. Maybe you can anchor it to Bahrain or to UAE, whatever is your preference, you can do that as well. Yeah, that's okay. You can do that.
And you mentioned something else about when you remove the key of that data, that means all the data has been lost. How the customer or the operator ensure that it is happened exactly or not?
So in a traditional scenario, right, if a server is faulty, what is your normal process, right? There is a repair and replace kind of a policy always applies, right? That means you say you unplug that server and return it for service. But you are not making sure your data that was there in that server is kind of erased, right? Yeah. So that is a big problem. When we say like there is a faulty server at your premises, when we say server, it's outpost server, for example, I'm saying it's a service, right? We recommend that you remove that key. That means you are making sure your server is kind of destroyed. That means AWS is going to go into a different recycle process. Okay, you return it. So that Nitro key, when you remove it, it is completely destroying your setup, data completely. Before that's like cleaned and sent out. That is more confidence for your customer, as a customer. Thank you. Thank you guys. Thanks for your patience. I think it's a lunchtime, Muscat. Please go ahead. Thank you.